In this video, we'll be covering the Python random module. So on the Python random module, you can do a whole variety of different things. Things from generating random numbers, doing simulations, generating test data to load test your server, or just for unit tests. So more than likely, you'll run into a situation where you need to generate some random data. Most of the random data that you'll need, you can accomplish by just using the built-in random module that Python gives you. So let's go ahead and import random. Okay, let's just start off by using the random method. So just print. What it's going to do, it's going to give us a value between 0 and 1. And notice that we got 0.614. If I just keep running these, it's just going to give them a random value. Okay, in this next example, let's say we want a number that's between a certain range, so like between 100 and 200. So we can just use a different method for that. So that's called the uniform method. And if I save that and run it, so we get a value between 100 and 200. And notice that they're all floating point values. There are also a number of methods that we can use to just generate whole numbers or integers. The first one we can do is it's called rand range. And if we go ahead and run that, so now we're getting integer values between 100 and 200. We can also just pass in a single parameter, and that's going to basically give us anything between 0 and 200. And there's also so similar to what we had here previously. So 200 is basically not included. So what we have to do if we want a number between 100 and 200, actually we'd have to put in 201. But there's a different method that can handle that. That is just called randint. And so now the 200 is inclusive. But other than that, they're quite similar. Another thing we could do is we can add an optional third parameter as a step value. So a step value is going to just return us even numbers. Actually, I meant rand range. So that is the first method that we had. And notice how we have all even numbers that are being returned back to us. And we can use pretty much anything as a step. So if we want anything like ending in 5s or 0s, we can just change that to 5. And then now we just have all, every fifth number is eligible in our range, basically. Okay, so there are also random functions for sequences. Sequences are going to be things like lists, tuples, anything that you can basically iterate through. A string could also qualify. So inside of a string, every character would have, each character would count for a single item in the sequence. Let's go ahead and create a few new variables here. Okay, so the first thing that we're going to do, we're going to just randomly pick a item in the list. And if we do that and run it, we just get one of those values in this list right here. So the same thing will work for a tuple. And it's going to be just very similar because they're both sequences. And then we can do the same thing with a string. So notice in the string, it's just going to return a single character. The next thing that we're going to cover is shuffling. Shuffling is basically the idea of just mixing everything up. Like if you have a deck of cards and you shuffle them, all the cards are just going to be in a random order. So we can do that here. If we shuffle and then print our number list, and basically our variable, which is our number list, got all shuffled. So the shuffling happens in place to our existing variable. So there's going to be times where you want to preserve the original variable and then copy it, basically create a new variable that has the shuffled values. So we can do that. We'll just have to, there's a couple of ways. So let's just create a new variable. and we'll just call it shuffled. So we want to call random.sample, and let's go ahead and use our number list again. And then so we need the first parameter is the sequence. The second parameter is the size of the sample. So since we're just shuffling everything, we want to make sure that the size is equivalent to the length of the list. So we just call the len function for length and number list. And if we go ahead and run that, and then so the reason why we'd want to do this is so our number list variable in this case will not have been mutated. So this should remain as it originally was. And notice, yeah, our original number list has not changed. It's exactly the same as when we initialized it. And then we have a shuffled variable or value as a separate variable. And there's one more alternative, so I'm just going to go ahead and comment this out. And I'm going to create the same variable name. So I'm going to call the built-in sorted method. So the first item is going to be the iterable, which is going to be our number list. And so this is going to be a lambda function, so when you set a key, and then right here we want to call random.random. And notice that the outcome of this is going to be something between 0 and 1, and it's going to be random, and that's what it's going to order by from low to high. So that will give us the same effect as calling random.sample and then passing in the length of the list. So if I save that, and let's go ahead and run it. And notice we just get a random shuffle again. And so sample is a very good way to just get a subset of your data, a random subset. So instead of, let's just say I want 3 of these, we just simply pass in 3. And let's just change this to sample. And then we're just going to just basically get random values, a subset of our data. Okay, and the next example that we're going to go over is just generating random strings. There are many use cases for this. And so what I'm going to do here is import string. And then we're just going to set up a new function. We'll just call it random string. And let's just give it a default length. And let's set up a new variable. Let's call it character set. And so we can use our the string module. And let's just say ASCII letters. So these are just basically any uppercase or lowercase letter. And then so we want to return. And we'll start off with an empty string and then join the number of characters that we want. So we want random.choice. And so our string of characters. Now if we just do this, it's just going to give us a string of just like one random character. So inside of our join function, we need a for in. So we'll say for I in range. And then let's just say that we want to pass in the length value that we passed into the function. And I'll set up a new variable called myRandom. And so we can just not pass in anything. We have a default of 32. And then if we just print our value. So then we get our 32 character string. And let's say 10. If we put in 10, then we'll just get a different value. So there's probably going to come times that we just want maybe to limit the character set to just a set of numbers or lowercase. So we can make our function a little bit better by passing in some defaults. Let's just say uppercase. And what I'm going to do here is just create a character set variable and then set it to an empty string. And then right here we'll say if uppercase. So if uppercase is passed in as true, so then we can add the uppercase letters. And remember string.ASCII letters, that's going to give us both uppercase and lowercase. So we want to change this to uppercase. Then we do the same thing for lowercase. And finally, we can do the same for numbers. To get a string of numbers, we just call string.digits. That's how it's defined in the string module. So if these are all set to true and we pass those in, then it's going to give us a value based on all these characters as one character set. So we'll just change this to 25. And then if we go ahead and run it, notice we have some numbers, some lowercase, uppercase. So what we can do here is we can change our parameters. Let's say we just want no uppercase letters at all. So we can do that. That's very easy. And then if we want all numbers, we can just set this to false. So now we should just get nothing but numbers. And that is a simple way of just generating a random string. Okay, simulations are another common use case for using the random module. So what we're going to be doing is a dice simulation. We're going to simulate rolling 2 dice a number of times. So we'll set up the first thing we're going to do is set up a constant. And let's say we're going to do 1,000 simulations of rolling the dice. And the possible values, so each die ranges from 1 to 6. So we can get snake eyes 2, which would be the lowest possible value. And since 6 is the highest value, then 12 is the highest possible outcome. So let's go ahead and set up a list of our possible values. So list, and we want to range from 2 to 13. And our stop value is going to be 13. The reason for that is because the range function is, so it's going to be index based. And since it's index based, the stop value is not inclusive, so it's going to give us a list between 2 and 12. So if we go ahead and print this just to make sure, and let's go ahead and run it. So we have a list ranging from 2 to 12. Okay, so the next thing that we need to do before we iterate and do our simulation of 1,000 rolls of the dice is we need a way of keeping track of the outcomes. So let's go ahead and create a new outcomes variable. So I'll say I, and then give it an initial value of 0. So we need a for in right here of the possible values, the previous variable we just created. So we're basically just setting up an initial dictionary for the outcomes. So if I were to print this, notice how every outcome has a value of 0. So with that, we can set up our for loop. We're going to use the for in to iterate through the simulations. And so we're going to set up 2 variables for one for each die. So we'll say D1. So we want to use random, and then a random integer. And if you recall rand int, we're going to set a start and stop value. So the 6 will be included. Remember rand range, the 6 will not be included, so we'd have to put a 7 in, but as long as we're using rand int, we can use 1 and 6. And we'll just call this one D2. So our outcome, we have to add the 2. Our outcome for one iteration through the simulation, we have to add the dice together. So I want to set a new value called outcome. We'll add D1 and D2. And then now we created our dictionary up here to keep track of the, keep a running total of the outcomes. So we need to apply that. So outcomes, and then our outcome, remember our key is going to be the actual number of the outcome. So we can pass that in. And we want to set that, or we want to increment that. So if every time we come in, we get let's say the simulation, it rolls a 6, we're going to add another 6 value to the outcomes to create a distribution. So just plus equals 1 as an incrementer. And so once we get through 1,000 simulations, let's just go ahead and print the outcomes. And we can go ahead and run it. Okay, so we did 1,000 simulations, and you notice that as we get towards the middle, so like 6, 7, 8, the tally is much higher, which makes sense because there are multiple ways to roll a 5 or 6 or 7 or an 8, versus there's only one way to roll a 2 and one way to roll a 12. So it would make sense that these would have higher numbers. So to make sure that we do everything properly, we can go ahead and check and make sure that these all add up to 1,000. So we can use the reduce function for that. So the reduce is a method that's available in functools. So let's go ahead and import that. We'll set up a new variable called check accuracy. So we're going to call reduce. And we're going to be using a lambda function to step through each value, x and y. And then we need to pass our all the values of the outcomes. So the reduce works as an accumulator. So as it's passing through every single one of these, the x is the accumulator value. And then as it goes through, it's going to add 29 plus 51 plus 74 based on this example down here. Reduces everything to a single value as our outcome. So check accuracy should add up to 1,000, which is our number of simulations. Let's just go ahead and print that. Okay, now we can go ahead and run it. Actually, what I meant to do here from functools, we want to import. So we don't need the entire module, we just need the reduce function. So that's why we ran into this error. So if we rerun it, it should work, which it does. So a similar situation, so we got our 1,000 down here. Okay, so the last thing that we're going to do is we're going to sort all these values. We're going to sort in descending order by the outcomes. So in this case, it looks like 8 would be first, followed by 7, and then 6. So let's go ahead and set that up. So I'm going to create a new value called sorted outcomes. We're going to iterate through all the items in our dictionary. So in order to get the similar structure back, we need to convert our result to a dictionary. So let's set that up first. Okay, now we can call the sorted method. So on outcomes.items, that's going to be all the items down here in our dictionary. And this is going to be another lambda function. And as we're iterating through the dictionary items, it's going to be like a list of tuples. So we want an index of 1. The index of 0 is going to be like the outcome, like the 2. And then the second item is going to be 25, which has an index of 1. And so we have to pass in reverse. That's so we can sort in descending order. By default, the sorted function is going to try and sort it in ascending. So the lowest numbers would have been at the top. And let's go ahead and iterate through the sorted items. All right, let's just go ahead and print this first. Okay, and then notice here we have 163 followed by 141, 131, all the way down in 2 and 12. Since there's only one way to roll 2 and 12, we expect those to be last with the smallest total. And if we want to just get like a percentage breakdown, we can do that. And let's just say percentage. Let's go ahead. Let's just round things off just to make it simple. So we want round item. We want the index of 1, which is the value, divided by a number of simulations. And so we're going to get a number between 0 and 1. So to convert that to a percentage, we need to times it by 100. And then 1 decimal place. And let's just put that in to give us some separation so we know one from the other. And go ahead and rerun this. Okay, so in this observation, the 7s basically had the highest percentage, and then it just slowly dwindles off, and everything is sorted in the correct order. So that was a simple simulation using the random function. Thank you for watching.